Everyone, this question is about finding the minimum area rectangle. The question here says that we are given points and we also have the points in a 2D plane. So we have to find the minimum area of the rectangle that can be formed from these points. And if we can't find a single rectangle, then we have to return a zero. But the trick here in this question here is that it says that the sides of the rectangle may not necessarily be parallel to x and y axis. It means that we can tilt the rectangle at any angle. We can tilt the sides at any angle. So that is the trick of this question. Now, if we were to solve this using brute force approach, the way we would do it is we will generate all the possible 4 points and check if they form a rectangle. And if yes, we would return that. But the time complexity would then be big O of n to the power 4, which is not very efficient in terms of complex time and space complexity. Time complexity. So herein, what we do is we use a geometric property of rectangle, which says that let's say this is a valid rectangle. It basically says that the diagonals of a rectangle are equal in length and share the exact midpoint. So what we can do is using this property, for every pair of points, we can treat the end of the 2 points as a diagonal, and then we can calculate the Euclidean distance in between them, and we can also calculate the midpoint. Now, if we find another diagonal which has the same midpoint and the same distance, we can then calculate. We can then consider that as a valid rectangle and calculate the area and update the global minimum as required. So this is the way we are going to approach this question. Now, all the given points all the given points that we have in our 2D space is unique, and the length of the point is less than equal to 50. So what we've done here is we have a map of string. Like this string is basically a serialized string which contains basically a midpoint and the squared Euclidean distance. And then we have a list of integer array which basically stores the uh, points that have the uh, pair of points which have the same midpoint and the same distance. So what we do is we are using a nested for loop in which we have generated all the possible set of pair of points, and then what we do is we calculate the midpoint. So in here, by the way, the formula says midpoint x coordinate is x1 plus x2 by 2. But here, to avoid floating point arithmetic errors, we have just used x1 plus x2. And in here, y1 plus y2. So this is our midpoint x and y coordinate. And then we have the squared Euclidean distance. Now, what we've done here is we have created a key, which is basically serialization of midpoint x, y coordinate followed by squared Euclidean distance separated by underscores. And then we add those points to the key. Now what we do is we have this global minimum, and in the end we are going to return this global minimum. But if our global minimum was never updated, we return 0, else we return the minimum area as per the question. So now what we do here is that we iterate through the diagonals, and basically we iterate through the map, and for every key we get a list of diagonals. Now if my diagonal size is less than equal to 2, it means for that particular key, I mean for that particular midpoint and distance, there was exactly 1 point. So it doesn't make sense. We can't compute the rectangle there. So hence we continue. So else what we do is we iterate through the list of diagonals that we have, and in there, what would be like, let's say I have this diagonal. So my I have this diagonal A index, then diagonal B index, and then we have the x coordinate, and y coordinate for both of the points P1 and P2. Now let's consider this -1 as P1 and this here, this as P2, like 0 comma -1 and 2 comma -1 as P1 and P2. So then we iterate through the remaining pairs for that particular diagonal, and for every pair we calculate the dimensions of the rectangle using the distance formula, and then we calculate the area, and then we update the global minimum. So this is how our code works. And coming to the time and space complexity, our time complexity is big O of n square, where n is the number of points. Why? Because we have used nested for loop. And coming to the space complexity, our space complexity is big O of n square. Why? Because we're storing the pair of points. So yeah, that was it from my end. Thanks for watching. Bye.